Dangal greetings and good day everyone. We are Group 2 and today we are excited to share with you our presentation about the 10 dimensions of the universe. In this presentation, we will explore each of these dimensions. Have you ever wondered if there's more to reality than what we see? While we live in a world of three dimensions and time, physicists believe that the universe might actually have 10. This idea is rooted in a theory called string theory. It challenges everything we know about space, time, and existence and could change how we understand the universe itself.
The idea of extra dimensions began with Theodore Kaluza in the 1920s, who suggested a fifth dimension to unify gravity and electromagnetism. Later on, Oscar Klein added quantum theory to this idea. Decades later, the string theory revived their work, proposing that the universe might have up to 10 dimensions to explain all physical forces and particles. In 1980s, the string theory gained momentum. Physicists discovered that the string, tiny vibrating energy strands, could only work properly in a universe with more than 4 dimensions. This led to a superstring theory, which requires 10 dimensions for the math to work and for the theory to stay consistent. Moving on, let's define some terms. A dimension is a direction or measurable extent like length, width, and height. Time is the fourth dimension, while the fifth to tenth dimensions are beyond human perception but necessary in theory. Meanwhile, the string theory is the idea that all matter is made of tiny vibrating strings instead of particles.
On the other hand, string theory and M-theory are the key to understand the 10 dimensions. This theory attempts to unify Einstein's general relativity, which explains the gravity, with quantum mechanics, which describe the subatomic world, while the extra dimensions help resolve contradictions between these two major theories. The first four dimensions are familiar: length, width, height, and time. The fifth dimensions introduce possible alternate realities, different outcomes of our timeline. The six dimensions let us compare these alternate timelines side by side, exploring the full range of what could happen.
The seventh dimension introduces completely different universe with the different laws of physics. The eighth includes all possible timelines within those universes. The ninth explores all the possible laws of physics, and the tenth is the point where every possible existence simultaneously. In string theory, particles are vibrating string. Each vibration type creates a different particle. These strings only make sense in mathematically in 10 dimensions. Without the extra 6 dimension, the theory collapses and fails to explain the force of nature.
So where are the extra dimensions? They are compactified or curled up tightly at the subatomic level, like a straw looks one dimension from far away, but it's actually two dimension up close. This explains why we don't experience this dimension directly. There isn't a single main equation stated, but the string action based on the Nambu-Goto action, it describes how string moves through spacetime. It also replaces point particles model in quantum mechanics and helps calculate forces in interaction across dimensions.
One major challenge is that we can't directly observe extra dimensions. They are too small to detect with current technology. Also, string theory isn't proven. It's a mathematical framework without experimental evidence. Physicists are still searching for ways to test and confirm its predictions. While extra dimensions can't be used directly, the math from string theory has helped in areas like quantum computing and particle accelerator design. The techniques from string theory are also used to improve models in nuclear and condensed matter physics.
Scientifically speaking, the 10-dimensional model helps the physicists understand how gravity fits with quantum mechanics. It also provides insights into black holes, the Big Bang, and what might exist beyond the observable universe. While we can feel the extra dimensions, we can relate it to things like 3D movies. They add depth beyond a flat screen, just as extra dimensions add complexity to space. Or think of Firefly. It works through invisible dimensions we don't directly experience.
This theory inspired the idea of multiverse, which is now a popular concept in science and even pop culture. The 10-dimension framework also influenced cosmology, help us to explore dark matter, dark energy, and the structure of space-time itself. Why these things matter? Understand the universe dimension should one day lead to a unified theory of everything explaining all force and matter. Truth is still theoretical. It laid a foundation for breakthrough we can yet imagine.
Talking about the problem, there is a major challenge, which is the experimental proof that no technology today can detect higher dimensions. Critics also argue that the theory is too mathematical and disconnected from reality, yet physicists continue to refine and explore its implications. However, future particle accelerators, quantum technologies, or even gravitational wave research might one day reveal signs of extra dimensions. This topic remains relevant because it addresses the deepest question in science: what is the universe truly made of?
The idea of 10 dimensions expands our understanding of space, time, and reality. It pushes science into new territories and invites us to question everything we know. Who knows? The next big discovery might come from a dimension we've never seen.